Hi, Glory. Good morning. Sorry, good evening.
Hi, good evening.
So happy to see you here. Okay, shall we begin?
Yeah, sure.
Yes. First of all, thanks everyone for joining us today. So let's begin. First, let me give you a small intro about Glory, so that then you can take over the stage, Glory. So Glory Price Emmanuel is a blockchain developer. She is a Web3 front-end engineer, technical writer, and tech content creator with experience in developing high-performance solutions. So she is also passionate about creating scalable tech products and has experience writing performant smart contracts and developing websites, web apps, and decentralized applications, which is TApps. So she is also deeply committed to educate people, particularly young women, about technology and assisting developers in becoming better at what they want to do. So she accomplishes this through technical articles on her blog. So you can visit her blog to get more details about still more details about blockchain technology. She was posting a lot of things about security. So you can go and check it out. So it's gloryprice dot hashnode dot dev. So that is its the link of blog. I'll drop it in the chat box as well. And she's also owning her own YouTube channel with tech content and speaking in meetups and conferences. She's also doing a wonderful job, like doing a lot of meetups and tech conferences. So thanks for that, Gloria, and you can begin your event. Thanks for joining us today.
Okay, hi. How's everyone doing? Okay, I'll need answers.
Yeah,
I'm going to be sharing my screen now.
Excellent.
Okay.
Excellent.
All right. I think the host, you need to allow me share my screen. I'm not able to do that.
Yes. Wait, let me see.
Okay. I think I can do that. Oh, I still can't share my screen. Okay.
Can you check now?
No, I can't still share.
Oh, yeah, wait, let me check. Make me the host again. Can you make me? I've actually made you as a host. So can you make me as host again?
Okay. Okay. Participants. Okay. Can't seem to find where to make you the host.
Yeah. Just check now.
Okay. Okay, I'm able to share now. I'm able to share. So I'm sharing my screen now.
Yes. You can start.
So let me just share my entire screen. Okay, so please confirm that you can see my screen.
Yeah, yours is visible, so you can start.
Okay. Okay, so hi everyone. Thank you so much for having me. I'm really excited to be here. So we're going to be talking about smart contract security today. So let's just start. The agenda for this meeting, at the end of this meeting, I want us to understand what smart contract security is, some secure coding practices, some vulnerabilities to watch out for, and security testing. So these are the things we'll be touching in the course of this meeting. So who is talking? I know he introduced me, but I would still do that. My name is Emmanuel. I'm a blockchain developer, smart contract developer. I also have worked as a Web3 front-end engineer for the longest. I write technical articles, and I just love to build tech products. I love to build things that people get to use at the end of the day. I'm also very interested in educating people about technology, assisting people become better at what they do, especially in tech. So you can find me on Twitter at Emmanuel. You can find me on LinkedIn at Emmanuel. You can find me on YouTube. Like you said, I have a YouTube channel at Emmanuel, and my blog. This is the link to my blog, glorypraise.hashnode.dev. So that's about me. So I really want this to be very interactive. I don't want to do all the talking because I'm not a teacher, but I want us to communicate. So this is like something we are going to do before we get into this talk. So feel free to unmute your mic and let us converse. So the very first thing, I want to find out if we actually have an idea of what smart contracts are. Before we talk about security, it'd be nice to really understand what smart contracts are. So please, can anybody tell me what a smart contract is? Feel free to just maybe raise up your hand, and I'm watching the participants. You could just raise up your hand or maybe just unmute and just say what you understand by smart contract, or what is a smart contract. Please, let's respond so we'll move fast. Anybody? Okay, yes, Femi, you can speak.
Okay, what I understand by a smart contract, right? It's basically the concept, right? It's so it's basically like a programmed script, right? That runs on decentralized what's it called now? Networks like Ethereum, right? And what it does is it has the ability to, I don't know, it's script, right? So it has the ability to do things almost automatically based on its programming. So yeah.
Okay, anybody else? Yeah, someone was speaking.
Smart contracts are the contracts used in blockchain process to execute electronic contracts between different stakeholders to take a decision.
Okay.
System will take a decision based on the contract or based on the code which we are entering as part of that process.
Okay. Awesome. Thank you so much. Thank you for answering. Thank you, Femi, for answering as well. Okay, so the next one is something that I feel like if you've been in the blockchain space or you've been in the Web3 space, then you probably have experienced this. I want to know if you've lost money in crypto, and just quickly tell us how. Let me start. So I think the very first time I lost money in crypto was when I wanted to get an ANS. I wanted to pay for an ANS, the replace dots. I think it was it. Yes. And I did not know that the wallet I was using on my MetaMask was compromised. So I transferred money from like my main wallet to that wallet, and it didn't take up to a minute. The money was moved out of the wallet. So that was the first time I actually lost money. The way it moved so fast that I just checked and the money had gone. Someone had moved it. That was because my wallet was compromised. That is one of the effects, or that is why security is important. So I don't know if anybody has a story to share on how they lost money in crypto. Maybe your wallet was hacked. Maybe you're doing a transaction and you went south. I would like to hear your stories.
Okay. I don't know if this relates to smart contract security, but I lost money by sending. So I participated in an ICO, right? Initial coin offering. And we're supposed to put what's it called now? An ETH address. Right? It's not an exchange address as our address so that they can send the coins to us, right? So I put an exchange address there. Okay. And so I think I invested around $200, and they sent those tokens to us, but it was sent to an exchange address, and I could not retrieve it. So I basically lost that money.
Oh, that's sad. Sorry. Does anybody else want to share before we move on? Or maybe you want to answer what your favorite programming language is. I just want us to converse what your favorite programming language is, maybe the most challenging thing you've done, the most challenging bug you've had to fix. Anybody? Okay, so let's get started. Let's get started right away. Okay, so are you ready? Yes, you're ready. Of course, you're ready. So now this is like an introduction to smart contract security. So what is a smart contract? You guys answered it pretty well. But if I'm going to put it in very simply, smart contracts are self-executing contracts with the terms of agreement written directly into code. Now, when these agreements are met, the smart contract automatically executes based on the instructions that was given to it based on the agreement. So it's self-executing in the sense that nobody needs to be there to checkmate it. Once you publish it, once you push it to the blockchain, it's capable of running by itself. So that's what a smart contract is. That's what a smart contract is. Now, smart contract security refers to the measures taken to protect the integrity and confidentiality of smart contracts on a blockchain network. So it's anything you do to ensure that your smart contract is safe, that your transactions are secured, to ensure that everything goes well. So anything at all you do, any measure you put in check or whatever you do, you put in place, you're basically doing smart contract security. So the aim of smart contract security is to avoid loss of funds, to avoid manipulators or maybe attackers attacking the system, to just ensure that everything works as it should. Now, there are some risks associated with smart contracts. One of it is the potential for unintended consequences due to bugs and programming errors. Now, just as any code you write, there's always a chance that your smart contract is buggy, or maybe you've made some errors in your code that could later lead to vulnerability or that could be exploited by a hacker. Then there's access control. When you're building a smart contract, it's very likely that you should ensure that you're giving access to the right people. The access that you give to a regular user is not the access you should give to the owner of the contract. If you mistakenly give a functionality that should be for the owner to a regular user, you know that anybody that notices that vulnerability can hack and attack your smart contract. So there's gas optimization. Now this comes in where, let's say a hacker is trying to just disrupt the service, maybe something like a DOS, and he tries to maybe like create an attack whereby the contract loses gas and falls short of gas, and at the end of the day is lacking gas. So you have to ensure that your contract is secure, that your gas cannot be tampered with, everything is working fine. Then decentralized organization, when you are doing things like when you need oracles, when you are trying to find sources of randomness in your smart contract, you have to ensure that what you're using is decentralized and cannot easily be manipulated. So we'll go into all of these things. Upgradability is when you're building your smart contract, you should keep it in mind that anybody can actually, there can be mistakes in this smart contract. So what happens if there are mistakes or if there are bugs in this smart contract? So these are the things that you should, these are like risk areas I would consider in course of this. So I don't know if you have any questions so far. If you have any questions about what I've said so far, feel free to ask before we move on. Okay, so I'll just count to 5. 1, 2, 3.
I think
Okay. Okay, said nothing. Okay, so let's move on to secure coding practices. Now, I will not be able to exhaust all of them because we don't have enough time for that. And we don't want to sleep here. We don't want to just stay on coding practices. But I try to highlight some of them that are important that everybody should know. So this is not like a comprehensive list. This is just, I think I have just about 5 here. So let's just move on with it. Now, the first one is design proper access control. One of the things I mentioned in the other slide was access control. So here I said, giving every network participant access to contract functions can cause problems, especially if it means anyone can perform sensitive operations. For example, minting new tokens. So just imagine you created a token contract and you put it on the blockchain, and in the course of creating that contract, you made the mint function available to everyone. What that means is that anybody that is smart or that maybe has knowledge about smart contracts or can program, that person can just go create mint tokens for himself. And before you know, you're having excessive supply, and maybe the price of the token can even drop because there is excessive supply. So all of those things would have not happened if that particular function was only accessible to the contract owner. So access control is very important because it ensures that only authorized individuals or group can perform certain functions within a smart contract. Now, I listed some ways that you can do this. You can set up a whitelist of approved addresses, or maybe implement a multi-sig transaction or a process whereby multiple parties are required to sign off a transaction before it is executed. That way, only people that have access, that's only the approved addresses or only the approved signers will be able to sign off a transaction. Another way is the use of roles. Now, roles are predefined sets of permissions that can be assigned to specific addresses. For example, an administrator role may be given the ability to modify the contract state, while a regular user role may only be able to make transfers. Now, before you write a smart contract, what I usually do is I really sit down to think of the whole process, how it's going to flow. While I'm doing that, I'll take note of who is going to be like the administrator, who is supposed to have access to all of these functions, who is the regular user, what functions are available to the regular users, so that when you're designing your smart contract, you're making sure that those roles are defined, so you don't mix them up. So I think I put a code example. I don't know if you're familiar with this ownable modifier, only owner. I think Open Zeppelin has a modifier called only owner, something like that. It just ensures that only the owner of the contract is able to access some particular function. So here, this is a code I cut out from a piece of code. It's not complete. So this constructor just sets that once the contract is deployed, the deployer of the contract is the owner. Then this modifier is created, and it requires that the person that is running that particular contract at that time is the owner. If the person is not the owner that was set on deployment of the contract, it should throw an error that says not owner. Now, this function is the function that creates a grant. So this is for a grant contract. It's not complete. Some things are missing. We check, some things are missing. But now, this grant function, it takes this modifier only owner. So anybody that wants to run this function would have to be the owner of the contract. If not, it's going to revert. So this is a simple way of checking. This is a simple way of implementing roles for access control in your smart contract. So I'm going to be moving on to the next one. Now, this is something that is very simple, but a lot of people don't do it, and it causes error. It causes havoc in the long run. Now, when you write your smart contract, always be open to ask for review. Now, a review can be in different ways. It could be maybe a group of people, it may be just one person, but at the end of the day, the person that is reviewing your code should be someone that is experienced. If not, someone that is not experienced will not be able to really spot out errors and stuff for you. So now the purpose of this review is to, there are several reasons, is to help identify potential security issues that may have been overlooked during the development process. It also provides a fresh perspective of the code. It helps build trust and credibility for the contract. For example, all these big organizations, things like DX, things like DAOs, one of the ways people can trust them is if their contracts have been reviewed and audited by maybe an auditing firm. So always ensure that your code is being reviewed by someone else. At the end of the day, as human beings, we may be tired. And when you're tired, you might overlook a lot of things. Or sometimes maybe you've gotten used to something and it just happens that you don't really know when you make those mistakes. But if you give your code to be reviewed, maybe you could just ask your friend or someone, please help me look at this code. And when the person looks through it, the person may spot out that, oh, you're not checking this error, you're not doing this. And you've saved yourself a lot of drama and stress at the end of the day. So ways of getting your code reviews. Now, this is for large code bases. You can use bug bounties, you can hire an auditing firm, or maybe get an auditor to audit your code. Doing pair code reviews, that's when your code is not very big. You could just find someone that is also a developer, and two of you look through the code. Okay, so moving on. The third, let's say suggestion, but yeah, this is the third step you could do. So you could use require, assert, revert statements to guard contract operations. Now, if I go back to this example, you see here that I'm using a require statement. So this is how a require statement looks. But let me go back and continue from there. So it's important to use require, assert, revert statements to guard contract operation in order to ensure the security of the contract. So now these statements are used to perform checks on the inputs and the state of the contract before executing certain operations. They help to prevent potential security issues such as reentrancy attacks, unauthorized access, unexpected behavior of the contract. Now, I tried to do a little explanation of what the difference between the three of them, but this is not comprehensive. We could go on to do a little more research about it. Now, require is used to validate inputs and conditions before execution. Assert is used to check for code that should never be false. Failing assertion probably means that there's a bug. Revert is used to abort execution and revert state changes. Now, I tried to give like an example. Now, these are just snippets of code. Now, this require statement is saying that if lock is true, or if lock is false, rather, because this I is saying that this is false. So if lock is false, throw the error message that cannot withdraw while another withdrawer is processing. Then the asset is also checking that my amount should not be greater than the amount that has been put. I'm sorry that this is just snippet. I just wanted to show you how it's used to ensure that you have this in check when you're writing your code. If I go back to this code, you see that because of this require statement here that has been added to this modifier, all of this code will not run if this is not passing. So just this now has protected an unauthorized user from accessing the rest of this code. So yeah, that's just how to use it. You can look out for that while writing your smart contracts. Okay, now the next one is test smart contracts and verify code correctness. Now, after writing your smart contract, before you even give it to someone else to audit or to look at it, you can test your smart contract. There are several ways to test your smart contracts. As we go along, I would explain them. I think I have them in some other slides. As we move along, we'll see them. So testing is a process of executing the contract code in a controlled environment to ensure that it behaves as expected. It helps to identify bugs and vulnerability in the code before the contract is deployed on the blockchain network. So I'm going to give some examples. Now, there are examples of testing, unit testing, integration testing, end-to-end testing. So it says that unit testing focuses on testing individual functions or modules of the contract. Integration testing focus on testing the interaction between different parts of the contract. End-to-end testing focus on testing the contract as a whole. Okay, so let me just talk about code verification. Code verification is a process of reviewing and analyzing the contract code to ensure that it is correct and secure. It involves a detailed analysis of the contract code, the contract logic, function calls, and data storage. I don't think I should be reading all of this. But yes, so let me give like a classic example of testing your smart contract. So now let's say you write a, I don't have an example. But let's say you write a vault contract. Now your contract is supposed to store money, and some people should be able to withdraw. Let's just say it's a typical vault contract. Now, after writing your contract, you could test it if you're using IDEs like Hardhat, Foundry. You could test it there. Let's say you could even move it to Remix to test, to see how your code will behave when it has been moved to the blockchain. I think that's another reason why test nets are there, for you to be able to test the code exactly the way it's going to function before it is moved. So when you use like a test net, you're able to test all the functions, you're able to do all the go through all the processes, and if there are errors, you'll be able to identify them and fix them before you move it to the blockchain. Because one of the cores of the blockchain, one of the core concepts of the blockchain is that it's immutable. So whatever you push to the blockchain cannot be fixed. So testing your smart contracts and verifying code correctness is actually very important. Now, code correctness is actually looking at your logic. You're looking at your function calls. You're looking at your data storage. Am I storing to the right? How am I storing my data? What is going to where? All of this is going to help you avoid some vulnerabilities that could be exploited on later. So let's move on. Now, the fifth tip I have here is implement robust disaster recovery plan. Now, let's say you have written your smart contract and you have pushed it to the blockchain. What if something goes wrong? What if there's a bug in it? What if there is an error that you missed, even if you've given it to auditors? Because you still see some of the hacks that happen, you still see that they were audited by big auditing firms. So what happens if that kind of situation happens? So you need to have recovery plans in check that, okay, if something like this happens, I can easily do this to stop loss, or maybe if loss has already started happening, to stop more loss from happening, or to mitigate the disaster that has happened. Now, some of the things you can consider as recovery plans. Number one is contract upgrades. Now, we know that when a smart contract is deployed to the blockchain, it cannot be fixed. It cannot be changed. But there are some EIPs that can help you with upgradable contracts. It can help you change, for example, using the Diamond standard, IP 2535, using the proxy. I can't remember the EIP. The proxy standard, using things like that would help you change those functions that are faulty in your smart contract without affecting the whole flow of the smart contract. So you should think about that while implementing or while building a smart contract. Another thing you should think about is an emergency stop. Now, an emergency stop is a mechanism that allows the contract to be halted or paused in the event of an unexpected failure or security rise or a security issue. So I can give you an example. I don't know, if you look at some big code bases, you will see that they have something like blacklist, they have something like freeze, that those functions are written and they are put in the smart contracts so that when let me say there's a hack or something, and money is being collected by unauthorized people, they can easily use the functions to stop the flow of money totally until it is fixed. So now let's say money is okay, let's say there is a let's say there's a token contract somewhere and somebody had access to it and the person is trying to mess it up. If there was like a freeze function there, on clicking the freeze function, the person will not be able to do anything on the contract. So that has saved you a lot of stress, a lot of headache. Another thing is event monitoring. So you should be able to track the event. That's where events are used in your smart contracts. You should be able to track the events to detect security issues or any unexpected behavior. When you're tracking your events, you know that, oh, this thing shouldn't be happening. And then you're able to do something about it. So those are like the ways that you could actually, those are like some tips, some coding practices that you should do while writing your smart contracts. I don't know if you have any questions about what I've said. If I go back, I talked about proper access control. I talked about reviewing your code. I talked about using guards, things like require statements to guard your contract. I talked about testing your contracts, verifying code correctness. I talked about implementing recovery plans. So if you have any questions in these things I have just talked about, feel free to ask before we move on.
Glory, I think someone asked a question in the chat.
Okay, let me check. Oh, yeah. EIP 1822. Yes, that's what I was talking about. So why revert is cheaper than require? Okay, that's a question. Is revert cheaper than require? Okay, let me go back to that. Is revert cheaper than require? I'm not so sure the gas that is being used when both of them are run. But I think if a straightforward answer would be maybe because the revert statement. So when you're deploying a contract, things like long strings in your contract can actually cost more gas. So a top of my head answer is the revert statement doesn't actually have any string. So it will most likely cost less than require, because your require statement can have a what's it called? For example, this not owner could be longer and it's going to cost you more gas in the long run than the revert that is just revert and the braces. So I don't know if that has answered your question, but I'm not really sure of the gas fees for both of them. So I'm not sure if it's cheaper, but that's like the closest answer that's coming to my mind. Yeah, for the slides, you get the slides as I'll send it as soon as I'm done. So is there any other question? Any other question?
Could you recommend any courses on auditing, smart contract auditing?
Can I recommend any what?
Smart contract auditing course, like if you want to become a smart contract auditor.
Auditor. Okay.
Yeah.
I can't outrightly recommend any, but there are some auditing firms that hold programs. They hold workshops on how to be an auditor.
Yeah.
So you could find one of them. Like I'm currently doing a program with Guild Audits. It's a 5 months. It's a 5 months smart contracts security and auditing program. So I think their next cohort is going to be out probably sometime this year. So I guess when you just look out for those kind of things, they'll teach you everything about, not everything though, but they'll teach you a lot about smart contract auditing. and they'll tell you
Could you
how they
recommend
work
their
as auditors.
YouTube channel? Could you recommend?
YouTube channels, I'm not so sure. I don't have any in my head right now, but I could check and then I'll send it to committee lead.
Can you
Yeah, someone
repeat
just
that
sent something.
organization name?
I didn't get that.
Okay, thank you.
Someone just dropped a link, so you could check that out. And if I have
that
any
link was to
resources,
you directly, you would have to share it to the chat yourself. I sent that link to you directly.
okay. Okay, so let me just copy it and paste so everybody can see it. Yeah, I just pasted it in the chat. So yeah, you can look at it. If I have any other resource, I'll share. Okay, so let's move on.
Yeah, like I know this firm, Quail Audit. I have my personal connection as well there. I had applied for their course. Let's see when they will verify and do that webinar.
Okay, that's fine. Okay, so let's move on to other things. Now, vulnerabilities to watch out for. Like I said, I can't tell you all of them. I'm actually doing a series on Hashnode, smart contract security series, where I'm publishing vulnerabilities. I think I published 3 today. So there are about 7, and I have about 30 to publish. So there are a lot of them, and that 30 doesn't exhaust the vulnerabilities that are available, that are currently known. And you know, every day we keep hearing of new vulnerabilities. So you need to like research a lot. And I put a link to my blog where you can see some of those vulnerabilities. But before then, let me just talk about these ones that I have here. Now, I didn't really exhaust them here because I've written all of these things in articles. So they are very detailed in the articles. Like reentrancy is a whole article on its own. This is a whole article on its own. Although I'm publishing them one by one. So I wouldn't really explain them in detail because there are articles that do that already. So reentrancy occurs when a contract allows an attack to repeatedly call a function, potentially draining the contract balance. So this is a hack that has caused, I think even the DAO hack that happened when, was it 2016 or when? It was caused by, it was a reentrancy attack. So reentrancy works like this. An attacker calls a function. So any function in your contract that is an external call, it does an external call. Someone can actually come into the contract through that call. So an attacker will just repeatedly call a function and continuously, let's say if it's like a transfer function, the person will keep calling the function until the contract loses all the money in it. And the money is being transferred to his own address, an unknown address. And before you know, you just check and you see that all the money in the contract has gone. So that is a reentrancy attack. I think at the end of this, I would go over to my articles to like try to explain 1 or 2 of them from the articles because this is not really comprehensive. Now, the next one here is the unchecked send. Now, when a contract sends Ether or anything at all to an untrusted address without checking if the address is valid. So when you send funds from a wallet or for a contract without checking the address you're sending to. Now, one of the hacks that we used to do, I don't have any code example here, but one of the hacks that we used to do is, first of all, you have to use require statements to check for address 0. Ensure that the address you're sending to is not a null address, first of all. Then if you have like a list of people that should be able to have access to that phone, you have to also check that list, that the address is from that list. If the address is not from that list, you ensure that the person is not getting anything. So before you send any kind of crypto, whether Ethers, whatever form of crypto or funds, ensure that you check the address before sending. Then the timestamp dependencies. Now, this vulnerability occurs when a contract relies on the timestamp provided by the blockchain, which can be manipulated by a hacker. I have an article on this. Now, if you check some contracts, you see that they use things like timestamp, they use things like block hash as maybe a source of randomness, or they use it as a value to determine something, to determine a function in the contract. Now, the bad thing about that is that the miners can actually change. You know, the miners are the ones that have access to, they are the ones that actually verify each transaction. So it can easily be manipulated by them. If not them, an attacker, which can be anybody, can also manipulate the timestamp or can easily check the timestamp on the blockchain, and the person has gotten that value. So when you use things like this as a form of condition in your smart contracts, then you know that you're setting yourself up for hacking, because it can easily be gotten without a lot of stress. Now, the next one is integer underflow and overflow. So now this occurs when a contract performs arithmetic operations that results in a value that is outside the range of the data type used to represent it. For example, let's say one of the variables in your contract is a unit 8. Unit 8 is a unit 8 variable. And now you perform a function, or you perform a arithmetic operation that exceeds unit 8. When it exceeds unit 8, which is 255, it automatically takes it back to 0. So the value, once it exceeds that 255, it goes back to 0. Once it's less than 0, it goes back to 255. So that thing can cause an error in your code, and it can cause, the error is now integer overflow and underflow. I have an article on this as well, so I'm not going to dwell there. I think after this we'll go there and quickly just look at some of these things. Now, uninitialized storage pointers, this vulnerability occurs. Let me just be checking. Yeah, I am. Okay, so I'm here just in case you're reading along. This vulnerability occurs when a contract uses a storage pointer that has not been initialized, potentially revealing sensitive data. So now this is when a particular function is calling, maybe it's trying to get a storage that has not been initialized. Of course, it's going to throw an error. Even in JavaScript, we have things that are, it's called scope. So if you're in the local scope, you cannot really access things that are outside that scope. So if something has not been initialized, it can cause an error. Now, the next one is which is this lack of exception handling. This vulnerability occurs when a contract does not have proper exception handling mechanisms in place, which can lead to unexpected behavior or security issues. Now, this is when you don't have checks that, okay, what if this address is a null address? What should happen? If you don't check all of those things, it can cause an error. So you should be able to handle exceptions. You should think of all of those things as a smart contract developer that is security conscious. You should think of all those scenarios and ensure that you guide against them in your smart contracts, because they can cause vulnerabilities. Now, unrestricted access, we have talked about this a lot already. This vulnerability occurs when a contract does not have proper access control mechanisms in place, allowing unauthorized parties to access or manipulate data. Now, we have talked about this. Well, example of this is when you're not using maybe an only owner modifier, so anybody can call any function. So we have talked about that. So these are some vulnerabilities to watch out for. Before I end this, I'll go over to maybe one article and we'll look at it and we'll move from there. So do you have any questions before we go to the last part of this talk? Any questions on vulnerabilities? Okay, let me check the chats. Okay, thank you for sharing, Femi. Any questions? Anything you'd like to clarify? Okay. Okay, thank you. Okay, so let's move on to security testing. I mentioned it at the beginning of this conversation. Now, security testing is performing analysis or evaluation of a smart contract to assess the quality of the code during development cycle. Now, testing makes it easy to identify bugs and vulnerabilities and reduces the possibilities of software errors that can lead to costly exploits. So it just helps you, before you've pushed your code to mainnet, or before you've pushed your smart contract to mainnet, when you test, it points out bugs, it points out possible vulnerabilities, it reduces costly errors that will cost you a lot of money and cause them to look for you. So there are two types. There's automated testing, which is the use of automated tools. It could be done by a software. It doesn't necessarily need a human being to do this. So these tools allow you to like test, then compare the predicted behaviors with the actual results. So like I said, they are automated. They are actually, most of them are tools. They are not human beings that do that. I would explain more of this in the next slide. Then there's manual testing. Manual testing is human aided. So it involves individuals testing steps manually. So you're testing maybe line by line, or maybe every function in the code. Now, this can be done by auditors, can be done by developers, can be done by anybody that is technical. But now the thing about manual testing, that it requires skill, and it requires considerable investment of time, money, and effort. Someone that is not a Solidity developer cannot test your code. That is error. And for some of these auditing firms, they would require you to pay money for them to audit your contract or test your contract. So another thing is that manual testing can also be susceptible to human errors, because human beings are not perfect, so you don't expect perfection from them. Okay, so now these are auditing testing for automated testing for smart contracts. There is functional testing. Functional testing verifies the functionality of a smart contract, provides assurance that each function in the code works as expected. And what else is there? Okay, so it requires understanding how your smart contract should behave in certain conditions. Then it helps you test function by running computation with selected values and comparing the returned output with the expected output. Now, there are three forms: unit testing, integration testing, and system testing. Now, this can be done. For example, let's say we are using something like Foundry or something like Hardhat to test, and you just fill in test scenarios in the script. I wanted to say for the bot, but it's not a bot. So you fill in test scenarios in the script. You tell it that, okay, when the balance is this, do this. When the this is this, do that. And it compares the results. It does the analysis for you, and it gives you your results that, okay, this is what will happen in this. This is what will happen in this case. So that's a functional testing. Then there's also static and dynamic analysis. So there are two automated testing methods for evaluating the security qualities of a smart contract. Now, static analysis examines the source code or bytecode of a smart contract before execution. This means that you can debug contract code without actually running the program. You're just checking the source code. Then the dynamic analysis requires executing the smart contract in real-time environment to identify issues in your code. Fuzzing is an example of dynamic analysis. I don't know if you know what fuzzing is, but a fuzzer feeds your smart contract with malformed and invalid data and monitors how the contract responds to those inputs. So it's, for example, when it's expected to throw an error, if it's not throwing an error, then you know that there's a bug there. So that's about automated testing. Then manual testing, there are mainly two forms: code auditing, which is a detailed evaluation of a smart contract source code. We have talked about auditing. So yeah, human beings are needed here to actually do that. It can be, okay, here in this line, you can see that it says code audits can be automated. We refer to human-aided code analysis here. Code audits require an attacker's mindset to map out possible attack vectors in smart contracts. Even if you run automated audits, analyzing every line of source code is a minimum requirement for writing secure smart contract. So even if at the end of the day, you've tested your code in an automated format, you still need to sit down and look at it line by line to avoid anything that maybe you may have missed or something, any error. Then there's bug bounties. So bug bounties are financial rewards given to an individual who discovers a vulnerability in a program's code and reports it to developers. Bug bounties are similar to audits since it involves asking others to help find defects in smart contracts. Now, the difference is that, yes, bug bounty programs are open to the wider developer or hacker community. Now, examples of bug bounty platforms are things like Code for Arena, Minify. Now, projects will bring their code and say, okay, we are going to put out this particular amount of money, help us find bugs. Now, these bugs will have different levels. There will be high severity bugs, there will be low severity bugs. So depending on which one you find, you're incentivized for that. You're giving something for that, like a financial reward. And some people actually make money doing this. That's their work. They don't do anything. They just sit down to find bugs in code, and they're rewarded for it handsomely. So that's for testing. I don't think I have any other thing there. Yeah, that's that for testing. If you have any questions, I think I'm done. Thank you. But before I go, let me go to an article.
You let us see your code.
My code.
The quotes. There was a quote there. That the mind is something, something, something. And
No,
that's like,
don't worry. Don't worry about the quotes. Don't worry about the quotes. Yes. Don't worry about the quotes. Yeah. Okay, so this is the vlog I was talking about. So I've written about, my goal is to write 30 and I'm almost done. So I'm publishing them as I can. So there are a couple of vulnerabilities here. So this is the integer overflow and underflow. You can check out other things I've written. Reentrancy, front running, state variable default visibility, TX origin. So let me look at reentrancy, because that was the first one here. So I don't know if I should read all of these things, or maybe you should just go and read it. There are code examples to show you how it works and how to avoid it. But yeah, I don't think I should go over this. I think you can just go over it yourself. Then if you have any questions, you can just revert for me to save time. So yeah, I think I've come to the end of this. Come to the end of this. If you have any questions, let me know. Yeah.
Glory, I have a question. Okay, this is an excellent session actually. This is very educative and we learned so many things. So as we know, most of these vulnerabilities, is it not possible to automate the existing vulnerabilities?
I didn't get that clearly. Is it not possible to automate what?
Is it not possible to automate the existing vulnerability, to fix those vulnerabilities, which will enhance the security of the coding?
It depends. It depends on the vulnerability. But how do you want to automate it? I don't know.
For example, if you take the vulnerability 1, okay, so this is the known vulnerability we know that
Yeah.
such type of things may happen while writing the
Yeah.
code or while executing the code. So
Yeah.
while doing that code itself, if you use any other method, automated tool or automated program to check that
Yeah.
whether this particular vulnerability exists in that particular part of the code or not before before putting that code into the live environment
Yeah.
while testing
Yeah. So
itself.
yeah, sure, you can do that. Now the thing is, I believe that maybe some of these auditing companies may have some of these tools that they use to automatically check for errors. But at the end of the day, now it depends on the code base at the second. Now, if the code base is very large, I believe that there are still tools that you could use to automatically check for these vulnerabilities. But these are like the common ways to, like, as a developer, I'm coming from like developer angle. As a developer, you should be able to like spot out some of these things and avoid them. Then before even, you should be able to fix all of these things before it should not even be a vulnerability for you as a developer. You cannot be writing contracts that can have reentrancy attacks because you know what to do. So if you know what to do, then you will not be having some of these errors in the first place. But I believe that there might be some tools that you could use to automate it, but I don't know any of them. I've not used any of them. What I know is code auditing, doing it line by line, checking, testing, all of those methods. Those are the ones I'm familiar with. But I believe there are things like that, of course.
Okay, so I have a follow-up question in that case. So when you talk about code review, so in earlier days, before this smart contract, any code, computer code, we used to do source code reviews. Is it equivalent to that source code review, or is it any different to that source code review exercise?
It's the normal source code review exercise. It's
It is
just
normal. Okay, okay,
yeah,
line by
yeah.
line. Okay,
There's no
okay.
line by line checking of your code. It's the same thing.
Got it. Thank you very
But
much.
there you're not doing it alone. You're getting a fresh eye to look at it because you might miss some things out. You get someone line by line review of the code, spot out any error. So yeah, thank you for asking. Any other questions? Okay. If there's no other question, I think the host can take it from here.
So, hey guys, do you have any questions? Anyone? Any participants? I hope everyone is clear about it. Anyone? No. Okay, fine. So that was so good, Glory. Thanks for this wonderful. One second.
Okay.
Wait.
So
So that was
since
so
there's
good.
no
And
yeah.
go ahead.
Okay, since there are no questions, so you guys are telling me that I
Yeah.
explained everything well. So thank you very much for believing in me. Please follow me on social media. Follow me on Twitter at Emmanuel Praise. Follow me on LinkedIn. I drop a lot of stuff on LinkedIn. Then I intend to do a lot of video content this year. So follow me on my YouTube channel. And of course, my blog. I believe by March, I should have put out the 30 vulnerabilities on my blog. God help me. So yeah, I'm looking forward to chatting with you. Feel free to send me a message. I would like to have conversations with you guys. So thank you very much.
Yeah, thanks, Glory. So thanks everyone for participating on today's event. And special thanks to everyone for your support. So let's wind up the session. So take care, everyone. Bye-bye. Have a nice day.
You too.